In number 1, we want to multiply two expressions that contain exponents, two exponential expressions. So we have a rule that tells us how to multiply exponential expressions that are of the same base. In this case, we have a to the n times a to the m. They both have base a. So if we multiply two expressions with the same base, we simply add the exponents. So we add n plus m. So let's apply this rule here. First, we're going to multiply the coefficients, and that's 35. 5 times 7. And now we're multiplying the powers of x. Okay, so we're multiplying like bases. So we're going to add the exponents, 6, and here there is an implied exponent of 1. When the exponent doesn't appear, there is an implied exponent of 1, so that's 6 plus 1 is 7, so that's x to the 7. And then we're going to multiply the powers of y. 2 plus 4 is 6, so that would be y to the 6. In number 2, we have a quotient, and so we have a division rule for dividing powers with the same base. So here we have a power of a to the n. And here we have another power of a to the m. And when we divide, we subtract the exponents. A to the n minus m, we subtract the top minus the bottom. This is true as long as a not equal to 0. So we're going to use this rule here. First, we're going to reduce the negative 5 over negative 15. We're going to simplify in the usual way, or reduce the fraction in the usual way. Let's divide top and bottom by minus 5. So on top we have 1, and on the bottom we have 3. Okay, and now let me just rewrite this. Let's rewrite. So we have 3 in the denominator. In the numerator we still have x cubed y to the 10th. And then we have in the denominator x divided by y to the 4th. So first we're going to concentrate on the powers of x, and we'll subtract exponents. So we're going to subtract 3, subtract 1. Remember, when an exponent doesn't appear, there's an implied exponent of 1. So 3 subtract 1 is 2. So we'll have x squared in the numerator. And then let's concentrate on the powers of y. 10 subtract 4 is 6, so we have y to the 6. And we still have that 3 in the denominator. In number 3, we have an exponential expression in parentheses, and it's all being raised to the exponent of 4. So I call this power to a power. So in this case, when we have a power to a power, we see here what we do is we multiply the exponents. A to the m raised to the m is equal to a to the n times n. So we multiply the exponents. So we're going to apply this rule here. All right, so basically everything is being raised to the exponent 4, the 2 as well. So let's start by raising 2 to the exponent of 4, and then also x cubed to the exponent of 4, and also y cubed to the exponent of 4. All right, so 2 to the 4th, that's equal to 16. And x cubed to the 4th, just multiply, and we get x to the 3 times 4, or x to the 12. And here also y to the 3 times 4, or y to the 12. Now, usually we won't put this intermediate step. Usually we would do the problem like this. Leaving out that step, we would just say 2x cubed y cubed to the 4th is equal to, first we do 2 to the 4th, we'll go straight to 16, and now we'll multiply the exponent here, x 3 times 4, and then multiply these, y 3 times 4. All right, skipping this intermediate step. In number 5, we're going to start by reducing those coefficients, reducing that fraction. So we'll divide top and bottom by 5. All right, so we have 2x squared over x to the 10th. And now, just like before, we're going to subtract exponents, even though now the exponent on top is smaller than the exponent on the bottom. But we'll still subtract those exponents. So we're going to be left with, well, we still have that 2 on top. 2 minus 10 is negative 8, x to the negative 8. And I could put a 1 in the denominator, but usually we'll just leave that out. So here's our solution. 2 times x to the minus 8. Now, we haven't really defined negative exponents yet, so let's do that now. In a minute, we're going to see that that x to the negative 8 is actually equal to 1 over x to the 8th. All right, so this quotient is really 2 over x to the 8th. So we'll see that in a minute. So we just saw that if we use our division rule, x squared divided by x to the 10th is equal to x to the 2 minus 10, which is equal to x to the negative 8. All right, let's do this again a little bit differently. We can divide top and bottom of a fraction by the same number. So let's divide top and bottom by x squared. So if we do that, in the numerator we have 1, x squared divided by x squared, the same thing divided by itself is 1. And here x to the 10th divided by x squared, we'll subtract top minus bottom and we get x to the 8th. So here we see if we use the division rule, x squared divided by x to the 10th is x to the negative 8. And here if we do the division rule, if we divide top and bottom by x squared and then do the division rule here and here, we get 1 over x to the 8th. So these must be equal to one another. So from this we see that x to the negative 8 is equal to 1 over x to the 8th. And in fact, we have another exponent rule which defines negative exponents. And here's the rule. A to the negative n is equal to 1 over a to the n, just like we have here. So this is always true as long as a is not equal to 0. So in general, if we do a problem like this and we get an answer that has a negative exponent, we'll usually convert that to something with a positive exponent. Let me also mention that if we have a negative exponent in the denominator, we can bring that to the numerator and the exponent becomes positive. So this is also true. 1 over a to the minus n is equal to a to the positive n over 1. In number 5, we have a quotient that we want to simplify. So let's start with these coefficients. Let's reduce in the usual way, divide top and bottom by minus 2. Okay, so we just have 1 on top. And on the bottom we have positive 3. All right, so let me rewrite. In the denominator we have 3x to the 5th y cubed. And in the numerator we have x cubed y to the 12th. All right, so let's say we start by taking care of the powers of x, and we'll just subtract. 3 subtract 5 is negative 2. So here we have x to the negative 2. And now let's take care of the powers of y. So we'll subtract 12 subtract 3 is 9. So we have y to the exponent 9. And now I would like to leave my answer without negative exponents. So I'm going to take this power of x with the negative exponent and just bring it down to the denominator. And when it comes down to the denominator, it becomes x to the positive 2. So here we have y to the 9 in the numerator, and in the denominator 3 x squared. In number 6, we're going to start by opening the parentheses on top. So we're going to use the rule that says a to the n raised to the m is equal to a to the nm. We're going to multiply the exponents. So let's do that. Let's start. Okay, in the numerator, first we do 2 cubed. That's 8. 2 to the power 3 is 8. And then x to the minus 4 cubed. Multiply those exponents, and we have x to the negative 12. And then the denominator, let's just copy that x to the 6. And now what I'm going to do is bring this x to the minus 12 down to the denominator. Leave the 8 in the numerator. It doesn't have a negative exponent. It just stays there. And the x to the minus 12 travels to the denominator as x to the 12. All right, so let's just multiply these powers of x, and we have x to the 6 plus 12, or x to the 18 in the denominator. In number 7, I'm going to start by taking this x to the minus 5 and just bringing it down to the denominator as x to the positive 5. Notice the 4 stays in the numerator, so does the y to the 11. And so in the denominator we have x to the 5 that came down from the numerator. Then we have this x to the 5 next to it. And then we have that y squared. All right, so now I'm just going to multiply these by adding the exponents. All right, 5 plus 5, so we have x to the 10. All right, now we have these powers of y that we can divide by subtracting exponents. So 11 minus 2 is 9. So we have that 4 in the numerator, and then y to the 11 minus 2, and then x to the 10 in the denominator. Here we have the expression 5 to the exponent 0, and we're going to use this rule that says that anything to the exponent 0 is equal to 1. And that's true actually as long as a is not equal to 0. 0 to the 0 is undefined. So just by this rule, 5 to the 0 is equal to 1. Anything to the 0 is equal to 1. 7 to the 0 is equal to 1. 3 to the 0 is equal to 1. Now, this rule sort of makes sense because let's say we had something, let's say we had the following. Let's say we had 2 to the 5th divided by 2 to the 5th. Well, this is the same thing divided by itself, so it's definitely equal to 1. The same thing divided by itself is always 1. And now if we apply the division rule and subtract these exponents, we get 2 to the 5 minus 5, which is 2 to the 0. All right, so it's a good thing that 2 to the 0 is defined as being equal to 1. It makes this division rule make sense in the case where both exponents are equal. In number 9, we're just going to use our power to the power rule. Let me just remind you of that. A to the n raised to the m, and then we multiply a to the nm. So we'll do that here. So first we're going to raise 3 to the exponent 4. All right, we'll do this in a minute. And then x to the minus 2 to the 4th, x to the minus 2 times 4, that's x to the minus 8. Now 3 to the 4th is 3 multiplied by itself 4 times. Let's just do that over here. 3 times 3 is 9. And again, 3 times 3 is 9. And 9 times 9 is 81. So this is 81. 81. 81 times x to the minus 8. All right, now what are we going to do with this x to the minus 8? Well, we'll bring it to the denominator. Let's say we write this as over 1. Anything can be written as itself over 1, so let's do that. And let's just bring this down to the denominator. So we have 81s left in the numerator and x to the 8 in the denominator. And number 10, we're going to start by opening the parentheses in the numerator. So let's look at that numerator. First we're going to do 2 cubed. 2 times 2 is 4 times 2 is 8. 2 cubed is 8. Then we're going to use our power to a power rule. X to the 4th cubed. 4 times 3 is 12. We have x to the 12. And then again, power to power. Y to the 3rd raised to the 3rd. Multiply those exponents and we have y to the 9th. 3 times 3. Let me just copy over that denominator. All right, let's now reduce the fraction. See, we couldn't reduce it at this point because the 2 was locked away in these parentheses. Now that we've opened the parentheses, we can divide top and bottom by 4. Okay, so we're just left with 2 in the numerator. Now let's take care of the x's, these powers of x. Let's subtract 12 minus 7, and we have an exponent of 5, x to the 5. And here, again, let's subtract 9 minus 10, and we have negative 1, y to the negative 1. And I'll just put a 1 in the denominator. And now I'm going to take this y to the negative 1 and bring it down to the denominator as y to the 1, or just y.